For anybody involved with nasal breathing, I think you will know the name of my next guest, and it's George Dallam. And the reason being is because he's synonymous with bringing the science to nose breathing. So this is going to be a conversation, nose breathing during physical exercise and everything that comes into that equation. So, George, you're very welcome. It's actually great to have a conversation with you. I'm looking forward to this one.
Good. I am as well.
And when we were talking in our introduction, you were saying that you had come across nasal breathing in 2005. So just a little bit about that. I'm intrigued. How did you become interested in breathing in and out through the nose? And was this during rest or sleep or exercise or all three?
Well, actually, like a lot of people, I got interested in this because I was having lots of health problems from the time I was very young and, sort of explored the normal avenues with physicians, and things didn't seem to work for me. So lots of upper respiratory disease. I started year-round swimming at 6 and water polo, about 10. And I was doing that all the way through college, started into triathlon about 1980. And I always had lots of upper respiratory infection. Once I moved to altitude out in the west of the United States, a large amount of sinus infections. And, I probably, by 2005, I'd probably had pneumonia 15 times in my life, 10 times, something like that, which is really extraordinary. And people think I'm exaggerating that because after a while, you stop actually even going to have it diagnosed. You just understand it. And, you got a couple of months, you're going to have to work through it. I was sitting at home one day. I was teaching here at this point in 2005. Had a sinus infection. It was a nice day. I wanted to go out. Didn't feel like I really should. And so I sort of opened up my brain and thought, well, where do you go when you're getting out of the box? You go to the internet. And I found this really interesting paper. And I don't know if you've ever run across this, Patrick. It was written by an engineer who coaches or at the time anyways, coached cross-country athletes in New Jersey. And he wrote the paper the way that an engineer writes a paper, analytically, which is appealed to my brain, right? And he talked about two things, one of which I was already pretty well versed in, the idea of really not wearing shoes or wearing very minimal shoes, which was the thing I had already been doing for a long time. And he talked about the idea of breathing nasally, which is the thing that had never even entered my consciousness while his athletes were running. And he talked about how valuable this was. And so I thought, I'm gonna try that, right? So by the next day, or as soon as I resolved whatever that sinus infection was at the time, I started doing my workouts, doing the portions that I could do nasally, which in the beginning was like nothing, right? I would start out on the treadmill in my warm-up, which is what you might call progressive warm-up, where you increase in stages. And maybe I could do the first stage or so, and then I would feel that air hunger. I'd feel like, wow, I'm suffocating. So, over time, though, within a week or two, I started realizing I could go a little further. Then I would start, that got me to realize I was adapting to this. I have to mention that at the same time, the other thing I found on the internet was the idea of using a neti pot, which is not a thing I was very familiar with either. And so I started doing that at the same time. I just started using one every day, not using one when I got sick, but just using one daily. And the result of this was that over about 6 months to a year, I fully adapted to breathing this way, both in cycling and running. I got to the point also by the end of that year in a corporate cup event we do every year, where I actually did faster times breathing nasally on both a bike and in the run a 5K run and a mile run in that case, and a 20K bike ride that I had done in all the previous iterations of that, which probably went back to about 1998 when I first started teaching here. And so, then I thought, okay, this is really working, basically because I just stopped getting sick the way that I had in the past. So my initial impression was, well, this is training consistency, right? But, later on, as this really worked so well for me, and I started influencing students and athletes I was still coaching, et cetera, to try this, they had sort of similar results, and we ended up doing the study based on that, right? Based on a lot of people who had chosen to go through an adaptive process over a period of years. And then we sort of started to understand this was more than just training consistency being improved. It was probably something beyond that, and that's where this economy kind of idea came from. So, I came to this naturally, and I'm I was really interested in because it really impacted me. And, as a scientist, we always talk about bias, right? And so you have to have concern when you look at science that I do about this bias, because I did have personal benefits and I still have personal benefits. But also, people who are not involved directly in science sometimes think that scientists aren't biased. We all are, right? We call that the hypothesis, right? What we do is create an approach to experimentation where we control for that bias so that doesn't influence the outcome. So I was pretty circumspect about trying to make sure that the studies that we did remove the opportunity for bias to play a role. So I definitely have a bias, right? I absolutely believe this is useful, and I, to this day, still religiously, breathe through my nose when I'm training.
I'm often intrigued, all of the sports medicine scientists in the world, and very, very few have shown any interest in breathing in and out through the nose. You are one of a handful. I cannot think of any more than maybe 5. And I
Yeah.
don't even think there is 5 sports medicine scientists who have investigated nose breathing during physical movement.
So
Why do you think that's so?
I think there are some reasons for that. The first thing is our field was premised on the idea that you would breathe from your mouth, going back into about the 1940s, when this field started to really emerge with stress testing and the ability to use a system to analyze expired gas so you could calculate metabolically how much energy you're using, oxygen consumed, CO2 expelled, all that sort of thing. From the get-go, we use systems where we clip the nose and you breathe through the mouth, because people just presume that that's what you had to do. And there's a reason for that. It's a very natural thing that if you begin to exert yourself beyond a level that you're accustomed to, you achieve a little higher production of CO2. That's an outcome of increased metabolism. And your body, essentially, and your brain, nervous system essentially tells you to deal with that most successfully. And the easiest way to reduce that is simply to increase your ventilation. So, of course, we can increase our ventilation quite a bit when we breathe through our mouths. So we develop this response kind of naturally. And then the third thing that's really significant is that, if we try to breathe through our nose, human beings really struggle with the idea, I'm going to have to adapt to this or slow down. They just want to go out and try to do it in the way that they normally engage in their physical activity. So if I'm a runner who normally runs at 8-minute miles, I try to go out and run at 8-minute miles breathing through my nose. And of course, right away, you're still at that stage not developed to breathe that way. So you're hypoventilating, meaning that you're ventilating less than is necessary to oxygenate your tissues adequately. So what you feel is this extreme air hunger, not from that lack of oxygenation, but because of the increase in CO2 that you experience. And, that's like this horror, I'm threatening your life kind of message that stops you right in your tracks. Even if you maybe consciously have thought about the idea that maybe there's something more than this, that's a hard thing to want to reproduce, right? So we never even considered the concept that, well, maybe that goes away, or maybe that's because of the condition of already having developed the ability to work breathing through your mouth. Maybe we could change that. That never really came in anybody's thought process. So a kind of another big idea, and this actually ties back to where I went to grad school. I actually went to the University of Arizona to extend my water polo career, but also because there was a scientist there by the name of Jack Wilmore, who was very well known in exercise science at the time. And he at some point, I think after I was an undergrad, got involved with a scientist, I think his name is Alan Morton over in Australia, who was very interested in asthma. And I think probably they formulated the idea of testing the ability to breathe through your nose, because late in the 70s and early in the 80s, there were some other, I wouldn't call them exercise physiologists, I'd probably call them physicians, who had examined the idea of doing that with people who had asthma, traditional asthma, and found that it actually inhibited their asthmatic response during exercise. So then they looked to see, well, what work capacity can you actually produce breathing through your nose? So they did what I still consider the hallmark or the seminal study on the topic, where they took undergrad students and basically had them do max test breathing through their nose, breathing orally, restricted to the mouth, and breathing oronasally. And they showed that, when you breathe through your nose, you impacted your work capacity, or the peak velocity you could achieve, by about 10%. You impacted your VO2 by about 10% at maximum. and your ventilation literally was reduced by about 30%. So even though their study highlights the idea that that breathing was more efficient, it basically says to people who read it, don't do this because you're going to impact your work capacity. And in the mind of athletes and of scientists who study exercise, something that's going to inhibit your work capacity is a non-player at that point. You're not that interested at that point. So again, nobody ever thought about the idea that, well, maybe you could move past that because maybe this way of breathing, which you don't normally do, is different enough that you might adapt to it individually or separately from the way that you adapt to all breathing. But that didn't enter the consciousness, right? If you were studying science and you found that study, you were basically like, this is a non-viable solution.
Yeah,
So it was only, go ahead.
So basically in 1995, that was Morton's study. So he was
Yes.
showing that VO2 max was reduced by in around 10% when individuals switched from mouth to nose breathing, given that these guys or girls had never trained, so their body hadn't adapted to it. Now,
Well, never trained breathing nasally. They had
nasally, yes.
Not necessarily untrained, but never trained breathing nasally.
Yes. Your paper as well in 2018, the VO2 was also reduced. I can't remember the exact figure. And it's still today a question that comes in, that there's so much emphasis on VO2. Would you mind just teasing that out a little bit in terms of, is it something to be of concern based on that the people in your study, they reduced their ventilation by 22% after they had adapted to breathing through their nose exclusively for 6 months during physical exercise?
Yes.
Will you tease that out a little for us?
Sure, that gets a little bit complicated and it gets into this idea that we refer to in exercise physiology as economy, right? So the fact that the subjects in our study in a steady state trial where they're running at a constant speed, it was about 85% of the speed that they achieved in their first VO2 max test, what we call the familiarization test, right? And so that was constant. We then had them run, I believe it was 10 minutes total and 6 minutes of data that we collected from that. We then had them run at that speed for about 10 minutes. Maybe, I think it was 10 minutes after we finished their max test. And so what we were looking for there was this economy idea, was the idea that maybe you can achieve the work using less oxygen. So most people understand this too simplistically, right? They think the higher your VO2 max, the better. But really what's important is the work at which you achieve that VO2 max. And in fact, historically, if we see two really high-level athletes achieving a very similar high level of work, but one has a lower VO2, we actually consider that that athlete is more capable because they're essentially able to operate at that high work level more efficiently, right? So that part never gets to the general public. They understand the idea that, well, higher VO2 max is better. Lots of coaches understand that, like it's the end all of your ability to perform. It really isn't. It's just a way to measure how efficiently you're performing. The end all of how you perform is the work you can do, how fast you can run, if we're talking about running, for instance. So that's the first piece, right? The second piece is that when you're breathing nasally and you've adapted to doing this, it's not that you're 22% less because you can't necessarily produce that ventilation. You're actually increasing what you could produce before you adapted to nasal breathing. So we absolutely understand, we're actually doing a study now to look at the full adaptive process. We absolutely understand that you can improve how much ventilation you can achieve nasally. So the main mechanism for that is probably the idea of, using your diaphragm differently. I think you've talked about this in your materials quite a bit. Because nasal breathing requires this higher resistance to be overcome, drawing the air through all the filtering apparatus, we engage our diaphragm differently. We have more use of the diaphragm and less use of the ancillary or intercostal muscles, things like that. We breathe more from the complete lung, the complete thorax, and less from the chest. So that actually is a thing you have to adapt to. An analogy that I think about would be like a cyclist, right? We increase a cyclist's ability to go faster, not only by pedaling faster, but also by increasing the size of the gear that they can pedal. So when you initially try to pedal a bigger gear for a given power output, at first you fatigue, but then your body, your muscles, skeletal muscles, they start to adapt to that. So when you start breathing more at a higher force level, but a little slower, it's sort of like using a bigger gear on a bike. your diaphragm has to adapt to that. But of course it does. It's a skeletal muscle. It's very adaptable. So partly how we increase our output breathing nasally is by adapting our diaphragm. There's probably also some stuff that's happening in the small muscles that allow you to flare your nose and open your nasal passage. There's probably some things that are happening internally that also allow better nasal airflow. But the big thing is you got to get your diaphragm to be accustomed to that kind of work. So then that gap between what you can produce orally and what you can produce nasally, it reduces. So you don't ever have to achieve what you can produce orally because nasal breathing is so much more efficient. So what do we mean by that? Well, when we take a breath breathing nasally, we can extract more oxygen out of it than we take a breath breathing orally, which of course we demonstrated in our study. And that's for a variety of reasons that get complicated. Probably part of the reason is because of the effect of nitric oxide. Probably not only allows you to maintain better dilation of your bronchi, probably also helps you in dilation of the blood vessels that are passing by the lung. So you get a better diffusion gradient, more blood flow passing by the lung. It also probably has to do with the fact that when we use that bigger force to draw into our air, an analogy I use in my book is it's sort of like opening a door that's stuck, right? When you finally get it to open, it transfers, all that momentum transfers and you go backwards. So if you think of the air being pulled in with this greater force, that air probably, no one's ever studied this directly, but that air probably distributes throughout the lung more, meaning that more of the alveoli are actually exposed to new air, which then improves diffusion, right? We definitely know that when we get more air exchange in the lung, diffusion improves because more alveoli potentially can exchange an oxygen molecule and a CO2 molecule. So all those things contribute to the idea we don't actually have to breathe as much. So we can sort of stop thinking about it as okay, now we're limited once we've adapted. Now we're limited by how much ventilation we can produce. The way I think about it is we only have to produce that amount of ventilation because our diffusion of oxygen is so much more efficient. We can draw more out of each breath. And that's without taking a bigger breath, right? That's in our study, we were able to illustrate that, during the nasal breathing conditions, these athletes or subjects were actually taking the same tidal volume, the same size of each breath, but they were getting this improved diffusion, extracting a little more oxygen. So then how much? Well, normally oxygen comes in at 20.93% or about 21% from the air around us. And during heavy exercise, it might be leaving at about 17 to maybe as low as 14%. So all we're talking about is like 1% more maybe, right? So maybe 17 becomes 16. So it's not actually a very big change, and we're still not remotely exploiting all the oxygen we have in each breath. We're taking still literally around a quarter of that oxygen out.
So can I just explain there? Sorry, George. So basically, so at sea level, atmospheric pressure is whatever, 760 millimeters of mercury. Of that, 21% is oxygen. So the athlete is bringing in 21%. The oxygen then, of course, is passing into the blood. It's doing a round trip around the body. And then normally, even during intense exercise, if I can interpret correctly from you, the athlete is breathing out 17%.
That's exactly right. And in fact, they're only taking out that difference, right? The difference between 21 and 17. Most of that oxygen just comes in and goes out again, right? It doesn't all leave and then return somehow.
And can I clarify, even if that's during maximum physical exercise, this isn't just about going for a jog. This is maximum intensity exercise.
I would say at maximum, you might get as low as 15%. During typical exercise, it might be more like 17%. That varies person to person a little bit. So the idea, though, is that nasal breathing, you only have to add maybe a 1% more, right? So maybe 17 becomes 16. You don't have to take much more oxygen. And if you think about that, the difference between, say, 21 and 17, is 4. That's roughly a fifth of the total amount of oxygen you have in the first place. So that fifth, right, or about 20%, maybe becomes like 21 or 22%. You don't have to actually extract a whole lot more oxygen just to allow yourself to breathe nasally, because again, it just works so much more efficiently. Yeah. So we think of this as some huge change that we have to make. It's really not, right? In fact, lots of people who are already well-trained can breathe nasally up to around their aerobic threshold without any specific adaptation at all. They just have to choose to breathe that way. As we push further and further, it literally or starts to really require some adaptation. But even at maximum, the values I'm talking about probably reflect maximum, right? Even there, the amount of increased oxygen we have to get out of each breath is a very small amount, right? It's maybe 1 or 2% of the total oxygen that we have in that breath of air that's entered our lung in the first place. So that's not a very big change. And it makes sense that we can do that because, again, we've evolved to breathe through our nose. That's very clear, right? Clearly, our mouth is an emergency mechanism. So here's what that means. Since we don't have to breathe nearly as frequently, like I think the difference between nasal and oral condition in our subjects was something like
10 breaths.
what was it?
49 to 39 breaths.
49 to 39. So literally
Yeah.
like 25% difference in respiratory rate. So because we don't have to take as many breaths, right, and we're extracting this little bit more oxygen out of each breath, it ends up that the total ventilation is actually substantially still lower. So that 22% lower ventilation, well, you're thinking, well, big deal, right? But it is a huge deal because ventilation requires skeletal muscle work, right? There's a significant amount of work being done by the respiratory muscles just to create that ventilation. So that ends up being somewhere around 10 to 15% near maximum. So if you take out like essentially about a quarter of that, right, that's a significant reduction in the work that you have to do totally, right? Total metabolic work.
Come back there. So just to explain that, George, sorry, I need to keep it as simple because I know you're very scientific.
No worries.
So just for the lay person listening in, every time we take a breath, the respiratory system needs oxygen.
Yes.
And what you're saying is during intense physical exercise, the oxygen that's going to support the respiratory system is about 10 to 15%. Now, you're also saying that once your athletes adapted to nose breathing, they just didn't have to work their breathing muscles so hard. So as a result, they weren't using so much oxygen up just to support their breathing muscles, which in turn then would leave more oxygen then for, say, the working muscles.
That's a very good summary, right?
Okay.
So in leaving that more oxygen for the working muscles, we can work a little harder because we don't have to devote so much oxygen. You could also think of it as blood, right? Blood flow. We can work a little harder. So maybe 2 or 3% harder. So, there's something analogous that we discovered in, I believe, the 1980s, where if you strength train a runner and they become stronger, they can reduce their total energy costs by about 2 or 3%, and they can run that a little bit faster. And so we devote a whole thing to that now in training athletes where, a significant chunk of time goes to strength training them so that they can run more economically. So we're talking about a similar amount of benefit by changing how you breathe and not doing anything else beyond that, simply adapting to breathing in this new way. So this is now why I think when after the year I spent, or 6 months to a year I spent really adapting to this, right, why I could run faster, even though I was already like 48 at the time. This is a long time ago, by the way. And I'd been doing the sport of triathlon already for 20, 25 years, something like that. You don't improve at that point. You're trying to slow down, getting slower. But yet I actually went in the other direction for a while and started to improve. So, that really got me to bite hard on this idea because I'm a performance guy. I was very interested and did it originally to allow myself to not get sick so much. But, I started realizing this is also potentially going to help our performance.
Wow. You made a couple of very interesting points. You were kind of surmising that when you're breathing through the nose, that it helps with alveolar ventilation. And I can remember a paper by John Lundberg. He's a professor of nitric oxide at the Karolinska Institute. And he showed that when you were breathing through your nose and you were bringing nitric oxide into the lungs, that nitric oxide resulted in a better distribution of blood throughout the lungs. And then Swift in 1988 showed that the partial pressure of oxygen going from the lungs to the blood increased by nearly 10%, the PaO2. So it's pretty much spot on. I find this stuff fascinating. Now, I'm going to come back to one question. What do you think is the adaptations that are happening? It's not just a biomechanical dimension. It's likely a biochemical dimension that the individual has a greater tolerance of CO2. What's your take on, there's probably a number of things happening there. If you wouldn't mind just going through that. So how does the
Sure.
athlete adapt to nasal breathing?
There's very clearly the idea, as well as improving my ventilation when breathing nasally, that I'm getting more tolerant to CO2. And so we saw in our subjects, when they hit max in their VO2 trial, I'm sorry, in their nasal breathing trial, they were at higher end tidal CO2 or PET CO2, pulmonary end tidal CO2. So what does that actually mean? The amount of carbon dioxide that ends up at the end of each expiration in that expired air, right? Which is how we measure. Just all of our measurements are air that you've exhaled, and then we measure the concentrations of gases in that exhaled air. So the amount of CO2 that ends up in your exhaled air is very directly related to the amount of CO2 that's in your blood. So, people who work with this, they actually have developed what are called predictive regression equations that have minimal error that say, okay, if this is your end tidal CO2, here's the level of arterial CO2. So arterial CO2 is the thing that's driving along this sense of getting enough air, or what we call your respiratory drive, right? So by virtue of the fact that their test was ending at a very similar or maybe slightly higher workload, but at a lower VO2 and a higher end tidal CO2, that suggests to us that that was not really a limiter. Their VO2 test, or maximal VO2 test when they were breathing orally, was ending at a lower end tidal CO2, right? Which suggests again that something else was limiting them. It wasn't this sensation of getting so much air hunger that they had to stop. And that suggests that they were very tolerant to CO2, right? That they could breathe in that way and not have that become the thing that ended their test, as opposed to other kinds of conditions. So there's also lots of work looking at the idea of how people adapt to changes in breathing that result in a higher end tidal CO2 and a higher arterial CO2 that show not only do we sense that initially as unusual, even if we know we're getting plenty of oxygen, but that we also adapt to it over time. So that kind of study's been done in resting conditions. It's been done around people who are doing hatha yoga breathing. We kind of know that this chemo reflex, right, this response to levels of CO2 is somewhat adaptable. So that is what I would suggest is the second big component of how we adapt to breathing nasally. We not only improve our ventilation a little bit, we also get more tolerant to CO2. That opens up a whole world of things that are potentially beneficial to us. So there's a researcher now at Baylor University working with students, and I assume mostly grad students. They've done 6 or 7 projects, and they're all focused on this idea of what's called a slightly hypercapnic environment that we can create by breathing nasally, which doesn't mean that we feel air hunger all the time. It means that in adapting to breathing nasally and not feeling air hunger, feeling that is normal, we also are slightly hypercapnic. And so the main theme of that is that level of CO2 is very important to the rest of the body's function, because it's one of our primary vasodilating metabolites in the blood. It causes our blood vessels to enlarge a little bit to give us better blood flow. It does that really everywhere because it's what we'd call a systemic mechanism. So it means our skeletal muscles get better blood flow, but it also means our brain and our heart get better blood flow. And so that has huge implications for significant health problems in modern culture. Particularly the idea that our brains are more susceptible to the entanglement of proteins, which leads us into cognition problems, dementia, Alzheimer's, et cetera, which we don't fully understand, but we know it's associated with the brain's ability to clear these proteins that are generated metabolically. And the main mechanism for that is just blood flow, and particularly, cerebral blood flow. So he did a paper with his students, I believe, that looked at this directly, where they were looking at subjects who were not adapted, from what I can tell from the paper, not adapted to breathing nasally, but were able to achieve a higher level of blood flow cerebrally breathing nasally at the same relative workload. Now that's complicated. They couldn't produce quite as much work like Morton subjects in the initial going because they weren't adapted, but they were at the same percentage of their VO2 max in each condition, but their blood flow cerebrally was better. So they measured that with ultrasound kinds of techniques that you can relatively readily measure blood flow.
You don't know how much better, do you?
I wouldn't put a percentage on it without having a paper in front of me, but 5 to 10%. It was
Yeah,
meaningful. Right? They
yeah,
talked about it as very significant.
yeah.
So then he later wrote a paper, which is also an excellent paper, talking about this idea of hypercapnia created by just breathing nasally, that has all these ancillary benefits, and all the work that looks at hypercapnia deliberately created in people. Essentially, we create hypercapnia in people by having them breathe a higher concentration of CO2 in the first place. So they breathe from a high CO2 source, and how beneficial that was in a wide variety of areas. So that's the really big implication of what we're understanding of this, that not only can we, do our physical work and not have to do as much ventilation, which might be performance, we also have all these benefits of simply being in that condition when we train, right? Dealing with stress and improving blood flow through the brain, probably improving our ability to prevent Alzheimer's and also to treat it. The thing we're talking about now is, which hasn't yet been examined directly, is this also probably improves blood flow into the heart, right? So one of the big mysteries right now and among exercise physiologists is why it is that people like me have so much fibrosis in their hearts. So when I say like me, I've been involved in exercise training my entire life from the time I was 6 continuously. Water polo, swimming, water polo, and led into triathlon. And while I have never had myself imaged and I don't appear to have an arrhythmia at this point, I would be stunned if I don't have significant cardiac fibrosis, meaning scar tissue in my heart, because multiple studies have now shown that athletes like me typically have higher rates of fibrosis and higher rates of arrhythmia as a result of that fibrosis.
So people might say, well, you have been really spending many, many years doing endurance intensity. How young might an athlete who is doing a lot of, say, ultra marathons or marathon running, like I'm sure it varies from person to person, but could somebody in their 30s be experiencing fibrosing?
I think that that's probably possible. The conditions that again, in this is a theoretical paper and we're just submitting it now, right? It's not yet published. In this theoretical paper, what we're trying to illustrate is that this is probably happening. It's happening as a result of oral breathing, and it's probably increased the closer we get to VO2 max, particularly once we get past the second ventilatory threshold, or what some people will call the anaerobic threshold or second lactate threshold. That the closer we get to VO2 max, the more the gulf between the amount of ventilation we have to produce orally versus what we have to produce nasally to get the same work done, to get the same oxygenation of the muscles, it keeps increasing. And that gulf is where this problem comes from. The more that we create a relative hyperventilation, the more that we wash out CO2, the less dilation that's being produced, and the more likely we are to create this condition where blood flow is actually impeded.
Okay, so what you're talking about is, say, somebody who's really doing pretty intense physical exercise, and at that point, then during oral breathing,
I'm going to pause you for a second there.
Yeah.
We see a gap from even low levels of exercise in terms of the ventilation you have to produce nasally versus orally. It simply gets bigger as you work harder. So I won't exclusively say that this only happens if you work really hard. Okay. I think that that's probably the strongest stimulus for it to happen.
So I'm also wondering here, George, we all breathe a little bit differently, and 75% of the anxiety population have dysfunctional breathing. That's reported, very understudied. In the asthma population, it's 30%. In the normal population, it's 10%. And out of that, chronic hyperventilation syndrome is the most common form of dysfunctional breathing. Now, if you have an athlete or an individual who has poor breathing from a biochemical point of view, that person is going to breathe harder and faster relative to somebody who doesn't have dysfunctional breathing. So I just wonder as well, within the population, so physical exercise causes people to breathe more air. And what you're saying is with mouth breathing, because they are breathing more air, there can come a point at which they breathe too much air relative to their metabolic needs, which causes too much carbon dioxide to be removed from the body through the lungs. This in turn is reducing carbon dioxide in the blood leaving the lungs, which, because of the loss of carbon dioxide in the blood leaving the lungs, it reduces blood flow and oxygen delivery to the heart. So the heart is really working hard, but of course the heart isn't a muscle just to pump blood throughout the body. The heart needs its own supply of blood flow and oxygen delivery. but it's not going to get it if the athlete is breathing too much air relative to their physical exercises. Am I reading that right?
You are summarizing that in the way that I think it's probably happening, exactly in the way that I think it's happening. I would say that it's getting compromised, meaning that at high levels of work, particularly, it's very likely that the blood flow doesn't match the need of the heart, and that creates what we call minor ischemia. So we understand from long-term resting science that if you repeatedly get minor ischemia, you're going to end up with fibrosis. And then the fibrosis leads you to having problems with the electrical signal that passes through the heart to cause it to contract without actually flowing normally. So those are what we call arrhythmias, right? So that we're essentially creating this patchy thing that interferes with how that electrical signal spreads through the heart. So then the heart doesn't beat quite properly. And there are hundreds of different variations on that, but the one that's been studied around this is atrial fibrillation, which is now almost a garden variety arrhythmia, meaning so many people seem to have it. And you could argue that the reason we're seeing this in athletes like me is because of this fibrosis, right? That they have higher rates of this than is normal in people who don't exercise.
Could it be possible? I know it might be a little bit of too much of a leap, though, but could it explain unexplained deaths in athletes as a result of cardiovascular issues, even though they may not have a prior history of cardiovascular disease?
So if we go back into the history of looking at this concept, it was all done in resting people. And what's been demonstrated at rest is if you say have a panic attack and you start to breathe much more clearly, hyperventilating, almost always through the mouth, right? That so drops coronary blood flow in some people that they actually arrest, meaning that they have a fatal heart attack because of the idea typically that they already have some existing atherosclerosis. So they can't really deal as successfully with a reduction in the amount of blood flow. So the idea that we're then, constantly putting ourselves at a little increased risk of something bad happening, an arrest or even a heart attack that doesn't result in rest during exercise because of how we're breathing, absolutely would tie right into this concept. So I'm suggesting that, if we thought about this differently, if we said, we're only going to do the amount of exercise where we can breathe nasally so we can maintain our myocardial blood flow, we'd not only be safer in doing that exercise, in my mind, we would also very likely limit the development of this fibrosis over time and these other ancillary problems that come from this as well. So those are all theoretical constructs you can go to if you accept the idea that how we breathe might actually compromise our myocardial blood flow. We have no study looking at that directly during exercise. We only have resting studies showing us that. But we do have the study we were talking about earlier showing us that cerebral blood flow is compromised during exercise. And since the mechanism is systemic, it's a pretty reasonable extension that maybe myocardial blood flow is also compromised. And then we have this end product, right? All these people have this fibrosis, and you're thinking people like that are supposed to be supremely fit. The reason they do this is so that their heart is stronger and able to better deal with, the challenges that create heart attacks in the first place. So we haven't been able to explain it. So what I'm suggesting is that's because we haven't thought about this in the right way, right? We need to think about this in terms of how our breathing is actually potentially changing our coronary blood flow in real time during the exercise. And so I'm hoping, I'm retiring. I'm retiring literally this semester. So I'll never do this study, but I'm hoping that somebody, picks up on this and does this study, sort of looking maybe at what the Baylor people have done, or maybe that group will do this study if they have the right imaging technology, because I think this will be relatively easy to demonstrate, right?
What are we going to do when you retire? Because there's nobody here to fill your shoes, because nobody else seems to be so interested in nasal breathing during physical exercise. George, people who are at high risk, we'll say people in their 60s, we start becoming more cognizant of cardiovascular health. Maybe they should be doing all of their physical exercise just because, a little bit older, going into that higher risk category, but also stress testing in hospitals.
So absolutely. I think I want to talk about something that's relevant to that idea of how to actually apply this. So, I have this ongoing study in one of my lab classes where we actually put it through the IRB. I don't know that I'll ever publish it because I don't have enough power in it yet, but I have about 8 subjects now. And, basically what we do is have the students try nasal and oral breathing during cycling at very low workloads. And we get 2 patterns of response. About 4 of the subjects were able to do this easily. And in fact, when they breathed nasally, it looked like our subjects who were adapted, their ventilation's a little lower, their VO2 is a little lower, their lactate levels are the same, their RPE is the same or lower when they breathe nasally. It looks like, hey, that's positive. And then there are the people who clearly feel air hunger and they report higher air hunger when they breathe nasally, and everything changes, right? Now, sometimes they even ventilate as much as they ventilated breathing orally. Their lactates increase, right, suggesting that they're not getting enough oxygen. Their VO2s drop pretty dramatically, right, suggesting, again, we're not actually oxygenating. So why is that important? And, maybe I'll try to publish it with 4 and 4, but it's not enough power. But I did write about it in the book because it's important. What it says is that there's a level that we have to be very careful about when we attempt to transition from breathing through our mouths to breathing through our nose during exercise. There's a level where we can do that and successfully still oxygenate ourselves. And then there'll be some level of intensity where we are now truly hypoventilating, meaning we're not producing less ventilation because we don't need more. We can't produce enough ventilation. And so then we become hypoxic, right? Then we don't get enough oxygen to our tissues. And so that's the thing you have to avoid when you're trying to make this transition that will keep you safe in doing so. So to do that is relatively easy and goes into the realm of how physicians and cardiologists particularly sort of evaluate people on exercise. We do what's called a graded exercise test. So all that you have to do to figure this out is do a graded exercise test where you're breathing nasally, right? So, tape your mouth or put water in your mouth, something that prevents you from breathing orally, and then start with very low levels of work and just progressing it based on what we call air hunger. You saying, hey, does this feel normal? And when you get to the point where it just begins to feel like, okay, this is not normal. Normally I feel like I'm getting enough air, but here I'm not. Then you just need to work just below that. And of course, over time, that'll keep going further and further up, meaning that you'll adapt and you'll go further and further without feeling any undue air hunger. So if we do that, we're avoiding that gray area where we work a little too hard because we can deal with air hunger, but where we're actually probably hypoxic and where potentially there's some danger, right? Where, if I'm a clinician, I don't want somebody who's operating in the realm where they're hypoxic, because they'll not only be hypoxic in their muscles, skeletal muscles, they'll potentially be hypoxic in the heart, brain, et cetera. So, but the point being that after we've adapted, then we probably can find our way even to maximum work without ever becoming relatively hypoxic or relatively hypoventilating in comparison to what would happen breathing orally.
Yes.
At that point, we're benefiting, right? Because that reduction in blood flow that has to go to breathing is available then to go to our heart and to go to our brain and to better oxygenate our heart and brain while we're doing the exercise.
Yeah, it's interesting though. Carbon dioxide is a compensatory mechanism that you spoke about earlier on. So I do agree with you. I believe all breathing exercises should be done within the comfort levels of the individual. We do dynamic breath holds as well. So we do actually generate intermittent hypoxic training, but we don't do hyperventilation beforehand. So say we have an individual walking or jogging or even fast running, we do have them exhale and hold their breath. We monitor their blood oxygen saturation to drop them down into the 80s. Now, the human body is pretty amazing though, because even though your blood oxygen saturation is dropping down because you've stopped breathing and your cells continue to extract oxygen from the blood, carbon dioxide is increasing because it can't leave the body. So as carbon dioxide is increasing, it's going to make sure that the heart and the brain is getting adequate blood flow and oxygen delivery. Just one of those things with the human body. Can I ask, just people with deviated septums, do you ever come across that? Do you use nasal dilators to help alleviate it? Do you ever see people when they switch from mouth to nose breathing, their nose will stream, it's uncomfortable? Can you talk a little bit about that?
So on the deviated septum side, I would say 2 of the 4 subjects in this lab class-based study, really struggled to breathe nasally because of deviated septums. Athletes, they had broken their nose at some point. We weren't using a nasal dilator in that study. So I would absolutely suggest, though, that it would be worthwhile trying a nasal dilator. The whole topic of nasal dilators is complicated because you have the external type, you have the internal type that's just in the nasal cavity, or prior to the nasal cavity. It's just before the first nasal valve. And then you have these insertable types that sometimes go past even the second nasal valve. So, the type that you insert that actually is like this mesh that can go and literally bypass your complete nasal passage, while that will bring you the ability to do maximal work instantly because it so improves airflow that you literally can achieve the airflow you can normally just get through your mouth. I'm not really an advocate of that because it's bypassing all the protective features of the mouth and also probably reducing resistance greatly as a result. So all the things that we actually benefit from are bypassed just to achieve a higher ventilation artificially. I actually had a company who manufactures one of these. I won't speak about who, but they were trying to get me to use one. So I did. I got it. And, I tried to insert the thing like 4 different times, and I literally couldn't bring myself to get it in there completely. I'm sure that, especially under medication, that they can be inserted, and that once you've done that once or twice, you probably can do so readily. I just was never able to. And, so they're also difficult to work with. Now, the other types of nasal dilators, right? So you have the type that's external, the strips that we're all familiar with. We absolutely have had science for quite a while showing us in the condition of nasal breathing that those increase ventilation, maybe 5 to 10%. And my practical experience, going to your other question, when I started adapting to this, one of the downsides of it was my nose was like hugely reactive with mucus. So, I was constantly having to clear my nose and literally carrying like a paper towel with me all the time, especially inside, right? Because I didn't want to offend people and stuff. And over time, though, that reduced.
Yes.
So I couldn't give you an exact time frame over that, other than to say that here we are 20 years later, and I don't even think about that anymore.
Yeah.
That's no longer an issue. The only time I get substantially more mucus than normal is if I go out in really extremely cold conditions that I haven't been in, and then I'll get a little more mucus than normal, but nothing undue. I can't just blow out a little bit, right?
Yeah, it's part of the process.
Well, I did use nasal dilators though in the early going. Is the point
I used them as
that.
well. My only exercise is on the machine behind me here. This is my training room here that I'm in at the minute. But I have to use them. My nostrils are just too compromised, but I have my own one. So it's an insertable one.
Yes.
Can I come across as well, just in your own opinion? So you're talking about your athletes exclusively breathing through their nose physical exercise. Do you ever give credence to how do they breathe outside of their physical exercise? And also, how do they breathe during sleep? I have a particular interest in breathing through the nose 24/7. Now, of course, there's times that mouth breathing is going to happen, but we're liking to minimize it. And I'm just wondering, has that come into being in the sports world?
I think it's entering the sports world. It really started to enter my consciousness later. So I started doing this about 2005. By 2006, I was pretty fully adapted to it. I'd say somewhere later, and I became aware of your book, and then in particular, I also became aware of breath, and read both those books. What is his name now?
James Nestor.
James Nestor. I read his book cover to cover. No offense meant by that. He's a great writer.
Yes.
So he made it really interesting, right? He's not necessarily accurately conveying everything, but about the science, but he's a great writer. So I just love reading his book. Anyway, at that point, I started thinking more about the additional stuff, right, in my own life. And now, as I talk to people about it, I find myself talking more about those additional aspects. How often are you breathing orally? Just a normal every day. So like when we do this, I taught, for a couple of years this way during COVID, and then I became acutely aware of how much my mouth was actually open. Mm-hmm. So I wouldn't be talking, a student be talking, but I'd realize, wow, your mouth is still open. So all of those things, right, they're what we would call operant behavior.
Say that word again.
Operant behavior, the idea that this is behavior that's unconscious to us. So I don't know if you've ever run across the Alexander theory or Alexander technique. He was all about
years ago. Yes.
So, his whole thing was not really about that. It was about how do you actually get that to happen all the time because it's operant, right? And he was not a behaviorist. He just figured out how to do that. So, we teach a lot of that in our curriculum now, this idea of behavior change, so that you can get behaviors to occur that you don't think about much. And so that applies here, right? How do you actually get yourself to keep your mouth closed? Well, a thing that I have long advocated for is the idea of manipulating your environment so that the behavior is produced in your environment sort of automatically as the best way to create this behavior change. So the classic example would be taping your mouth or putting water in your mouth. which again becomes a thing that you can also do outside the context of exercise, in particular during sleep. So I started doing the nasal taping thing during sleep probably 2 or 3 years ago to right away to some effect, meaning I was sleeping better and not turning as much. And in particular, the thing I felt very vulnerable to was the idea of waking up in the morning having had my mouth open because I had rolled to an intermediate position on my back, and then gravity actually causes your mouth to fall open. Mm-hmm. So I got kind of interested in the apnea stuff. There's only 1 or 2 studies yet looking at this idea, but the one study that's there looking just at the occurrence of apnea in people who have it shows that with a mouth taping at night, apnea occurs less. And the mechanism is ridiculously simple. Probably most of our apnea is simply because when we get on our back, gravity causes our jaw to drop and we open our mouths. Regardless of our body composition and all this other stuff we think is related, that's such an obvious mechanical thing. And taping just prevents that, right? So now, if I end up, and I actually find now I sleep on my back much more than I used to. I find though that my mouth doesn't have that experience, that thing of opening and becoming very dry the next morning or being dry by the next morning, which I think is greatly improving my sleep. And so I'm a big advocate of what you're saying, right? That this is not just during exercise, although I think exercise it can have a huge impact because when you do this during exercise, your rate of ventilation is very, very high compared to the rest of the day. And if that ventilation is negatively impacting you, not just in terms of your physiological response, but in terms of things like inhaling pollutants, et cetera, doing something that it changes that is hugely valuable. But the idea that it also might translate back into keeping your mouth closed the rest of the time, I think is absolutely the case. But I think when it gets to what we're doing right now, right, I can either think about whether my mouth is staying open or I can think about what I'm saying to you, and I have to think about what I'm saying to you. Yes. So, an operant behavior change, something that allows you to achieve that without having to think about it, is also very valuable.
Yeah, it's not easy to do.
I just manipulate the environment, water, tape, something like that.
Yeah, it's not easy to do when you're communicating.
No.
Yeah, we would love to see it because in terms of obstructive sleep apnea, I think without a doubt, breathing in and out through the nose with the tongue resting in the roof of the mouth, you've got better recruitment of the diaphragm. And also in terms of having improved breathing patterns during wakefulness, so it translates into lighter, slower, deeper breathing, meaning good recruitment of the diaphragm during sleep, and it will help to reduce resistance to breathing to help prevent collapse. I wrote a scientific paper on it with 2 ear, nose, and throat doctors, but it's peer-reviewed, it's been published, but nobody as of yet has got a cohort of people and tested them with established obstructive sleep apnea. Let's change their breathing patterns, improve it from a biochemical point of view, a biomechanical point of view, a psychophysiological point of view, and then check what impact has it had on sleep. So, this is again, breathing kind of just gets a little bit forgotten about, but I think it's happening. Now, we have myotape, by the way. So instead of taping here, we have it now, but I have a vested interest in that. It's my own product. But I did it as well. Part of it is to people with obstructive sleep apnea, they have to be allowed to mouth puff. Yeah. Otherwise, if we just close the mouth, and if they can't mouth puff, it can worsen their AHI. So it's a very understudied topic, but I think it has got big potential given the CPAP, which is the gold standard of treatment. It's only got a 50% compliance rate, So you have 50% of the population there, and where do they go? George, I'm conscious of time. I think this has been a wonderful conversation. You have a new book. Can you tell us where people can get it, how people can find out more? And are you done writing papers now on nasal breathing during sports now that you're retired?
Well, we'll submit this paper that we were just talking about, and then I'm unclear on if another paper is coming or not. I'll probably remain interested in this topic. And so the study I referenced, where we're taking people who have never done this, and we're looking at their VO2 max up front, nasal, oral, then we're trying to take them through an adaptive process. Then we're looking at it on the back end as well. That study would go on for years. So I'm trying to transition a couple of my colleagues who are interested into continuing the study. So I'll probably stay involved at least in that study for quite a while. I suspect 2-3 more years to actually get enough subjects to have enough power. And that's just to get to like 10 subjects. So I'll probably still stay involved on some level. I want to emphasize to you, though, that there are a couple of new in the last maybe 3 years people who are really interested in this. So the gentleman at Baylor I've never met, I've just been reading his papers. He's a guy you should probably talk with, right? Because he clearly has a very strong interest. His studies are all looking at various ancillary topics around the idea of what happens when you breathe nasally during exercise. And it looks like he has a cohort. He's taken through at least 8 weeks of adaptation in 1 or 2 of the papers. And I'm hoping that that cohort is continuing so they get to that 6-month point where they're fully adapted and he could look at things like VO2 max. Anyway, he has a great interest, and he's contributed way more than I have to this field in my estimation because of the number of different studies he's done in a short period of time. There's another gentleman who's gotten interested in this, who's well known in our field when we talk about training methodology, 80-20 training, if you're familiar with those ideas. He's gotten interested in this, I think probably because he has his own atrial fibrillation issue, and he's an ongoing training athlete. So he's done a couple of studies he does really good work that were really well done. So I'm very encouraged in that when I first started looking at the science around this pretty heavily, maybe 5 to 8 years ago, nobody, right, had interest going back until you went to the few people back in the 80s and 90s. And now it's emerging again. I'm seeing more and more and more papers come out. So there's also a couple of different clinical trials. There's a group over in Spain that's been doing something where they use a device that's designed to block off portion of your nasal flow so that creates more resistance to breathing. They've done a couple papers that are really interesting. So, to me, that was my main agenda, right, is to try to get the people who are interested in studying this or try to get people like myself interested in studying this. Because once you get them to sort of turn the thought process, then everything else follows from there. And I think you've been doing the same thing for a long, long time. So I'm greatly appreciative of the stuff that you've done in the same way. So I'm enthusiastic about that, and I probably will never move away from it completely, even though I'll be retired.
That's good to hear. Your new book.
Oh, it's called. So you just have to remember paradox. Called the Nasal Breathing Paradox During Exercise. It's a fairly big publisher, Kendall Hunt. So there's a bunch of booksellers already have it. So if you can just either remember my last name, which is unusual, Dallam. So it's like Dallas with an M instead of the S. Or you can remember the nasal breathing paradox during exercise, or even the nasal breathing paradox. You'll come to those booksellers and, you'll be able to find it. Okay. There's an e-version, I think, and a little cheaper. And also, if you're somebody who's interested in this, doing something around the field, I can actually get a copy of an e-copy for you to read for free. I don't have a huge ton of hard copies, although I have some of those too. So
I'm interested in everything nasal breathing. It's been my life since 2002 and before that. So yeah, totally. What would you say, just with the last couple of sentences, somebody who is a bit skeptical? Normally I'm told that breathing through the mouth during exercise is bullshit, and that's what's being quoted to us. Yeah. Could you give us a couple of sentences from a scientific point of view to help counter that?
So that's a hard one, because I can't say just try it, because when you just try it, you're going to feel air hunger, right? What I could say is, I've been doing triathlon for 42 years, and I'm pretty good at it. Yet I'm doing this, right? So if it was bullshit, I would have long ago discarded it. I could say that, I guess I'm really you trying to use my own credibility. I've also, done a fair amount of work on it as a scientist, and that work is supportive of it. People, if they don't want to, so I have this friend, Nicholas Romanoff, he sort of started talking about how you should run a long, long time ago. And people said the same thing to him, Patrick. They would literally scream at him sometimes in presentations and, say exactly what I'm sure you've heard as well. And, that used to make Nicholas crazy, but he just persisted. And now, when you go to like a PT who's working with your running technique or running coach, they all talk about the things that Nicholas elucidated in his concept. They don't like to use his name or reference what he calls the pose method. But the core principles of how we teach running are, in fact, the pose method. people don't understand it well enough. So, and they don't like the fact that he made money doing that, right? Because they don't understand the guy was a legitimate academic who came to this country with nothing because his daughter had moved here, and she asked him and his wife, who was also a professor, they came here. He had to figure out a way to survive in the United States. So he took his ideas and he commercialized them, yet they're still of huge value. So you're not exactly the same scenario, but people don't want to accept things where somebody has devoted their life to it easily. But over time, that breaks down. It starts to normalize. More and more people experience it. And that's what we're going through, right? It takes about 20 years in my experience before people will generally say, hey, you know what? They were right? That enough people have now done this. They've normalized it, that this actually has huge potential benefit. So, it's just patience, really. I'm speaking to you now, Patrick, because I know that you face some of that probably. You just have to be patient. You just have to keep reminding yourself, the science supports this, right? The legitimate science supports this. Whenever I see somebody in my profession talking about it, they never actually have read any of the science, right? I've seen a number of people either ambushed or actually deliberately say, this is all bullshit, but they don't refer to any of the actual science around it. That's based in their ideology that they learned as an undergrad, typically. When we used to think, we never even considered you could breathe through my nose. A real short, quick thing. Back at the U of A, when Jack Wilmer was there, I remember being a grad student, and we were talking, and this fella came through who we didn't know. It was said he's from Australia, and they said, yeah, he's trying to study nasal breathing. The guy's like nuts, and we all laughed. Right? This was back about 1980. And I don't know if this is if this guy was actually the Australian Morton who did this study, or if he was just some grad student that knew him. But 10 years later, Jack did this study with I've lost track of his name. I can't remember if it's Allen or not, but with Dr. Morton in Australia, where they looked at this, and clearly he had an interest. So it wasn't nuts. It was just so far removed from our experience that we just weren't even willing to consider it. And, that's always the case in humans, right? That's how they are. They don't like to change their ideology, their, way of thinking about things. So,
wow.
But it happens over time.
Well, if anybody isn't convinced after that last few sentences, I'm not sure what would work. So it's been an absolute pleasure. Thank you so much, George, and enjoy your retirement. And of course, we hope that you're going to still contribute the way you've contributed to date. So thank you so much.
Well, Patrick, it's been a pleasure talking to you. And you've led the way on this, right? You're the primary motivating force around this concept. So I congratulate you on your career, and I know you're still going at it hard, because every day you see these people getting better. I don't do that clinical thing, so that's very powerful.
Thank you so much.
Okay, bye-bye.
Bye-bye.